the art end of the spectrum. Anouk, it's a great pleasure to welcome you to the stage. Ladies and gentlemen, this is Anouk Wipprecht. And there you go, the slide comes up. FashionTech designer, which is an amazing thing. I'm so looking forward to hearing about your work. Over to you.
Perfect. Thank you so much, and it's wonderful to be here. I was at PLS last year, and I already saw the lights and the stage show, so it's really fun to be part of that. For the last 25 years, I've been trying to connect fashion and technology and robotics and lights around the body. So I use things like microcontrollers, sensors, and all kinds of electronic, small electronic components that I put in garments and into, from costumes to stage wear and such things. And I'm going to tell a little bit about that. Yeah. In a second. Either way, I can go. Yeah. Let me see. Yeah. Okay, let's see if this works. That's okay. So so for the last 25 years, I've been pushing a field that I call FashionTech, so the combination of fashion and technology. For me, that's really fun to do as a woman because, of course, there's a lot of still inequality between women and men in the field of especially engineering. With a lot of the companies that I work with, we try to get a kind of a 50-50 by 2030, but with current things, that's sometimes not even close to that, especially in the field of electronical engineering. So the thing that I try to do with FashionTech is not only making engineering fun, but also beautiful. And I think that attracts a lot of females to this field. So I work a lot with universities, writing curriculum, and also seeing by, for example, what I do, creating robotic fashion, robotic dresses, and such projects. It attracts a lot of females into this field that might not thought of coding before or working with engineering or robotics. And for many, it opens up a new thing because, I like to build drones or maybe electric cars and such, but not every woman might want to do that. But a lot of people are interested in this idea of fashion and technology and the combining of electronics on the body. So I do two things. I measure the surroundings and I measure the body itself. So in regards to measuring the surroundings, this is one of the things that is quite interesting. So these are spaces around the body. So the intimate space, the personal space, the social space, and the public space. And these are spaces that we all have around us. There was somebody called Edward T. Hall in the 60s. He was noticing that different people have different personal spaces. And he started to write about this, in this case, in a book called The Hidden Dimension. And he traveled around from culture to culture, place to place. And the way that he measured these spaces was by a wooden stick, so a physical stick that he went up from person to person to measure these spaces. So basically in one of my researches, I take these spaces and I take these measurements from the spaces. And what I try to do is measure these spaces again using digital means. So what I use are ultrasonic rangefinders, proximity sensors, doing heat mapping, looking at invasive versus non-invasive ways that we can measure these spaces on the body while walking around through different cultures, of course. So that's exposing a lot of problems in regards to privacy and such as well. So one of my projects is this one. It's a robotic spider dress. And it has robotic legs on the shoulders. And when you walk into these spaces and the personal space, for example, this dress is reacting, it's attacking. And it's not just attacking in one way. I programmed something called 12 states of behavior. So depending on how you walk into this dress and where you're entering the personal space and where you're standing in the surroundings around this dress, it's reacting differently. So, for example, when I presented in the United States, people always stand in a sort of circle around it. But when I presented in the Netherlands, where I'm from, in Amsterdam or something, people tend to come like really fast, very close by, and really provoking the design sort of. So I can really see that people have different personal spaces, and also how culturally these behaviors are, and they coexist with the behaviors that my dress has, and the interactions that my dress has in this case. So these dresses are fully 3D printed, and I'm going to tell you something about that in a little bit. But all the mechanisms are basically based in here. So from little servos that are in here to servo controllers that are under the shoulder plates, and what you saw before in the little movie, the controller and the battery pack are in this case all on the back. Another of my dresses is with Italian architect Niccolò Cassas. In 2009, we figured out that we could 3D print really big pieces on printers, in this case Materialize, and we wanted to team up to create a dress for this. And that is an earlier version of one of my other dresses. It's based on an octopus or an inkfish. It pushes out ink so it can basically escape. So it uses basically the same sensors, so ultrasonic rangefinders, but instead of a one-on-one interaction, it measures when people are in the direct surroundings of this dress, and the more people, the more it starts to smoke. So I'm using the same sensors, but basically a different interaction from the interaction design part. So one step is basically sketching out these dresses, which can be by hand and in a computer, sort of seeing where all the components need to go. In this case, the smoke needed to go into the kind of the hip area, which you can see here. The smoke turns around and then is being pushed out these little areas here in the side, sort of. So the smoke creates a really nice kind of flowy thing instead of like being pushed out. The process that I'm using, and that's not new now, but that was new back then, sort of, is selective laser sintering. So you can see a CO2 laser beam goes into a little box with a little mirror, goes into the process chamber. The cool thing about this process is it's a powder printing process, so you can go into really intricate detail. And basically, when you take it out, all the powder falls off, and this powder is also partially recyclable. So that's kind of the cool thing about this technique. So here you can see the dress in my studio. I'm using different kinds of silicone fluids. I have multiple versions of this dress. This one is with a hot nozzle, pushes out kind of the smoke. It also has lights in there that also pulse with it. And when I'm going to a space, I need to see if what kind of silicone fluids I'm using. If there's a lot of air in the space, if it's heat and all of that stuff, I have different silicone fluids that I use for that. And this was a project for the IAAA in Germany in 2012. So there were in total 6 dresses, and in that time I wasn't really sure how to connect, so I connected it over the DMX controller of the booth through XB, so Zigbee protocol. So each of these dresses has a little Zigbee or an XB in there that I was connecting it to, which was kind of a fun and experimental way to connect these dresses. The other cool thing is these dresses were working for multiple days, so for me it was really cool to test them out, sort of. Another of my dresses is a cocktail dress, but a real one, because it really makes cocktails. So by the push of a button, it creates a little cocktail. It has a peristaltic pump, and you can see that turn, sort of, and when it turns, then it pushes through the fluids to the front. So that was kind of a cute, fun thing that you can do. I created these for Cirque Du Soleil, which I've been working with since 2012. I don't work on their theater shows. I work on like a lot of side events, because for me that's fun. So we had a club in Las Vegas, and we had fashion week. A lot of things that we did for that, and also this dress was shown at a place called Heart Ibiza. It was the restaurant of Cirque Du Soleil in Ibiza. So this is a little bit the peristaltic pump in the back. It's from an open source company called Party Robotics, and that's the one that I'm basically connecting to. And this was the restaurant that it was being served in multiple colors. Later on, we also made Designed for Boys. So we also had Cocktail Boys, and the logo was there from Hearty Pizza, sort of. It was a collaboration with the Adria brothers, which are really cool chefs. So what I'm trying to do is trying to see if and when I do this sort of, when you connect different kinds of technologies on the body, what it can do other than just blinking and bleeping. So how can it become more social and playful, like the cocktail dress? How can it be more defensive and behavioral, like the spider dress? Or how can it become more expressive and sensitive, like the smoke dress? And also how design informs the engineering, how the engineering informs the design. So really seeing fashion as an interface, a social interface, a playful interface, and also an emotional interface. With my work, I do a lot of collaborations. One was with car brand Audi when I was in Germany working with them. What I thought was really cool about that, it was a full team of females, of girls, and what we didn't want it was to project females that are like kind of tigering over Ferraris, which you see a lot at the car shows. We really wanted these girls to kind of embed these kind of almost car-like costumes, sort of. So I created a collection based on the Audi A4. And that was kind of a really, really fun project. I took out kind of the parking sensors and the LED matrix technology and put that back in the dresses. And you can also see some of the design elements that we put back in there, sort of. So when you're working on these projects, a lot is about like simulating and seeing where things can go. Can things open up? Can things be kind of projection mapped upon? Or where can these things go, sort of? And after a lot of like testing, so a lot of mock-ups, a lot of prototypes, you come to kind of final designs. The problem with this project is I think I had only 6 weeks, and the last dress that was going on the car on the catwalk was still kind of wet because it needed to be cured fully. So sometimes you do not have too much time for this. So the prototyping is pretty rapid sometimes. So this was the projection map dress. So while the models were alive walking around, they were being projection mapped on. And of course, this is 3D printed model, also the dress. We could easily projection map that on there. And other things were like, these lights were like super, super bright. And of course, on the body, so using also the shield itself as kind of a heat sink is something that, that was used while placing all the other the bug pucks and all of that stuff on either the back or in the back piece itself. So this show went on to China, and it traveled to America and all of that stuff, presenting both the A4, the car, and also this collection. That was kind of a cool thing there. Another thing that I really like is when these technologies don't only go on the body, but also become a part of the body. And for that, I had the pleasure the last more than 10 years to work with this super badass girl. Her name is Victoria Modesta. She's a bionic pop artist, and she lost her leg pretty young on in life. And instead of kind of having a prosthetic leg that looks like a real human leg and hiding it underneath your trousers, she really wants to show it and create more awareness for people that are kind of differently abled and more project herself as this cyborg, sort of. So with her, I did a bunch of legs, I think 8 or 10 legs I made for her. The one that you can see here to the right is based on the smoke dress. She steps in it, it starts to smoke. Other things were during Art Basel, Miami, in the Zaha Hadid building with 3D printed instruments from Eric Goldenberg from Studio Nomad. And this leg was an accelerometer based. She could move it and then kind of create music with it. She could sonify the music with a Tusk body piece that she had on. to basically shows. This leg is for a show here in Paris for the Crazy Horse showcase, sort of. It's in the middle of Paris, sort of burlesque-like, that she had a residency, which is this one. In that case, this needed to withstand a longer amount of time. So these were EL panels that I put in a kind of a spike leg. To the other piece that you can see here was a little turning point. So when you put lasers in it, the lasers went everywhere, sort of. So it's really fun to work with Victoria, because in her missing leg, I can of course put a lot of electronics and see what that can become. To this product, this is one of the last products that we did together, because she undergoes currently an operation in where her bone becomes an osteo operation, where the pin comes directly out of her bone. So currently I'm working with basically her residual limb and sort of a socket and a pin that goes into the leg. And currently the pin is being injected in her bone. So one of the problems with using pin socket or a pin liner is that when you sweat, it's very slippery. So when you're walking and you're starting to sweat when it's a warmer environment, it starts to slide around, sort of, you know. So having the pin come out of your bone, of course, eliminates that. So it's pretty cool, but it's also very experimental operation. That is why we haven't been able to work together for the last few years. So because she's still undergoing that, which is really, really awesome, because it's from such an experimental nature. But just before that, we had the opportunity to do this for Rolls-Royce. And we already did a lot of things, and I proposed, like, hey, what if we make a really small Tesla coil and we make a Jacob's ladder effect in your leg, your void space within your leg, because we got really good at making her lean on the two little side points of her leg over the years, sort of. So that is basically what we did. So I'm first going to show you the little fashion movie that she made with Rolls-Royce, and then I'm going to show you some of the process. Sorry, that was the end. Anyway, this is, it was a movie of 6 minutes. You can find it online as well. That we recorded in Los Angeles. And basically, when we were brainstorming, sort of, mostly what I do first is creating a mock-up. So it doesn't look nice, it doesn't look pretty at all, but it's just to kind of test out the electronics, especially when it's experimental from nature. Then I start to make kind of the prototype, and that's kind of what you see here. So on the left, you can see kind of the mock-up, so the mock-up setup. And yeah, the small Tesla coil, you can see here the Tesla coil in the heel of the shoe. The board with also like a heat sink underneath it. So basically it goes from here to here. You could see the effect happening. And then I'm basically repeating the effect to here. And there I can steer these, kind of the Jacob's ladder effect from point to point, sort of. And it became one of the smallest Tesla coils that has been made, and definitely one of the smallest Tesla coils that has ever been in a prosthetic leg. So that was the fun thing about that. There were a lot of problems with, of course, making sure that the electricity doesn't mount to her leg, because I'm also using carbon fiber in this process. So yeah, there's already a small space that you need to work with. And also a lot of kind of challenges, but that also makes it really fun. So going into stagewear, is of course that you guys are all very much known to. The time that I got to America was for the Super Bowl. I did Fergie, her costume from the Black Eyed Peas, which I can show you here. I got asked when I was still in the Netherlands, and I got asked for a football show, which is really small in the Netherlands, but I did not know that the Super Bowl was so big in America. So when I got there, I was like, ooh, okay, that's something different. But yeah, I also saw that, of course, there's a lot of light, there's a lot of space, everything needs to be really visible. So that was something that I really wanted to make sure that that happened. In that time, there were new kinds of LED. They're called Rebel LEDs, and they got really, really warm. So in the backside, they got really, really warm, but they were really, really bright. So that was kind of what I wanted from them. And the same time, Swarovski came out with a kind of a mesh, a metal mesh, that I thought was also very unique. But I could also see the possibilities of using kind of the metal mesh and the Swarovski crystals and putting these Rebel LEDs in there. And basically, it became a really big heat sink, so a wearable heat sink that she could wear. And because these Rebel LEDs were just so super, super bright, it was really, really well visible, which I, of course, wanted. So the battery packs are under the shoulders, and she also had shoes with optic fiber that I created the optic fiber at Luminex in Italy, to make the density there as well, sort of. So that was the cool thing about that. So that's a little bit about stagewear. The other thing that I mentioned is body signals. So I talked a lot about measuring the body and the surroundings. You can also measure the body itself, of course, and do things with that. My background is basically fashion design, couture tailoring. Then I went into interaction design, machine learning, and robotics. That is basically my study. So within kind of the electrical engineering and interaction design part, it's important to think of like your inputs and your outputs. As input, I use a lot of like sensors. As outputs, the effect is happening, whether that's smoke, that's light, that's robotics, and such on. As input, of course, you can use a lot of things. So EEG, so the brain, so brain signals. I'm going to tell you a little bit about that. EMG, so muscle contraction. There's places on the body that you can do that really well. EDA, so galvanic skin response is really good to measure pH or stress response. Respiration, so the way you use your lungs, you breathe. Mostly measured here. Accelerometer, we already mentioned. There's sort of the heart rate and the heart volume. For respiration is really interesting for me because you get a lot of like kind of emotional data out of it, much more than kind of the heart rate. So yeah, all these things are really, really interesting to kind of measure. So one research project that I did was with Swarovski. So that was also the dress that I started with. It's called the heartbeat dress, and it basically shows the heartbeat from a frontal positioning. And they wanted to build that into kind of a little necklace. In this case, the necklace can be built into the dress or into a collar, or you can just have it as a standalone on your neck. So the process was sitting together with the designers of Swarovski in order to see how we can cut the glass, but also make it a 3-point touchable. And then, I was looking at how I could create a system that was small enough to put on the back of this crystal and also do measurement of the frontal position, the heart rate, measuring it from that position, which you need to do a lot of noise reduction in machine learning to measure out the baseline. But what was really cool is just the way that the crystal was like shining. Of course, they're really good at that, but it was really fun to work with them on this. So this is what I mentioned, so that it can be used in a dress. You could put it as a modular thing in a dress, then the whole dress would light up, and you could also have it just around your neck. It's the smallest PCB board that I ever made, sort of, on the back of this, because it did just like a lot, and pushing that all on a really, really small board, again, is a really fun challenge, of course, but also proposed a lot of problems. Another project that I did, and these are a series of 3 projects I did around brain signals. I was doing an artist in residency at Ars Electronica, which is a really big media center in Linz in Austria. And they told me, you can do anything, but you're not allowed to make a dress. So that was their only thing. So I was like, okay. I was interested in, because I was working with Philips for a long time, Philips Medical as well, in doing something around kind of clinical testing, and also something with it's something like psychology or something like that. So I contacted some of the hospitals And I came out with Barmherzige that was around Linz, and they had a whole autism and also ADHD research center where they were working with children. And what I wanted to do was kind of measure the brain signals and see if I could do something with focus. So I came into kind of the testing group with children on the spectrum with ADHD. And what I did was create this. It's called Aging Unicorn, in where I was doing research to basically measuring anything and everything surrounding them, so the sounds and also visuals. So there's a little camera in this headset, and then correlating it to their brain signals. And especially when their focus goes high, this camera would start to record. So it would start to feedback us and also the children, like, anything and everything around you has an effect on you. And when you have ADHD, that effect is a little bit more kind of appealing and out there, sort of, you know. So it became a really fun way for these children to work with brain signals, to learn a little bit about that and also learn about their own behaviors. So the process was embedding cameras in the headset. What I didn't want it was, this is the 1020 system of medical EEG, in where you use 64 electrodes in order to measure things in a right room with a doctor. I really wanted to make it very kind of playful. So one thing that I wanted to see if I could eliminate some of these channels. In a medical situation, you always need to look at the full brain regions. You cannot really do what I do here because that's called more experimental. But by that, I was doing a measurement, it goes a little bit out there, but it's called the P300 or the P3 wave from the event-related potential. And what I wanted to see is if I could measure the focus using this P3 wave. And for me, it was also a way that I could create a sort of a headset situation on the head using this mohawk situation. So that is basically what I started to research. Then again, going back to your design, put all these channels in there so I have the right reference points. And that became that kind of experimental device, which looked like that, and then it's built in and it looks all pretty and proper. But that became kind of that whole research thing became a success because it was a new kind of playful way. And for the children, it was really cool that they could put it on themselves and also put it off themselves out of free will, sort of, you know. And that was kind of really pleasurable for also the researchers to work with, that you don't constrain a child, because I think that's just a really bad thing. It was out of free will. We also made them later into different colors, which was really fun for these kids, sort of. And out of that, because it became a success, we created a BCI out of it with the company G-Tech in Linz. So this is the unicorn hybrid bag that we still do like hackathons with, and it's in a lot of universities, and a lot of people use it actually to do some research around brain-computer interfaces from the medical grade, because you can buy nowadays a lot of BCIs. In that time, you could buy them, but they were not really, they were more doing measurements from the frontal positioning of the head, and you could not really see it from a medical side too much. There was too much, different noise in there. We do brain-computer interface designer hackathons with it, and also every April we do a BCI Spring School where people can join for free, and they can learn about the world of neuroscience and BCIs. So if you're interested in this, it happens next year again in April. So that was a success, and basically we went from 46 to 8 sensors, and then here we did the opposite. With that company, G-Tech and university in Linz, we went to 1,024 channels. So from 46 to 8 to 1,024. And I built this dress with it, and each interaction of this dress, so its movement, its light, and its sound, so there's all like different kinds of lights and all of that stuff, was in a direct connection with one of these 1,025 channels. So we did that, which later on became the Pangolin grid. We use it now for stroke rehabilitation, but in that time it was an art project, sort of. But it's being used in hospitals right now. So this was the dress, and then when you looked at, in this case, Dalietta, she worked with us a lot. We measured her brain signals, and she at one point, she could not control the dress in the beginning, but at one point you can see, as you work more with brain signals, that people can see, like, okay, this is a neutral position, this is a more hectic state, and a more like relaxing state, meditative, sort of. So that was kind of the fun thing about this dress. And again, it became a kind of a live visualization of these brain signals as they cut in, sort of. So you can read a little bit about that at IEEE Spectrum, and also there's some papers around that, which I'm not going to bother you now, because I want to also show this one still. So this is one of my latest dresses, and again, my focus on BCIs and brain-computer interfaces, but here, in this case, looking at the workload. And I combined it with my love for googly eyes. So yeah, so you can see them here. The cool thing about these screens here, they're touchable and they were also round, so I could easily kind of integrate that. I'm measuring the workload, which is kind of interesting from the data side. Workload, so you're never fully 100% on or fully 0% off. It's always between 20 and 80%. And I was looking at pupils, it's the same. You're never, the pupil's never fully out there and never away, sort of, so it also ranges between 20 and 80%. So what I'm measuring is the workload, and the more workload there is, the more the pupil opens up. And again, it's a direct correlation to the measurement of the workload and the percentages in there. Other than the heartbeat rest, it goes on the body, it measures your baseline, and it works, sort of. When you're working with brain signals, you need to go through a little training phase in where it measures out, in this case, your brain signals, and also your own kind of leveling there. In this case, we have something called a spell check, in where you need to look at, kind of verify and look at certain, letters. And then basically automatically using machine learning, it correlates that to your brain signals and what is coming in. And it creates this baseline sort of interaction on which the system can work. So the testing phase is around 2 minutes, 1 minute 50 to 250 minutes, sort of, and then basically the system is working. So that's the only thing with the use of brain signals, that you need to go through a little testing phase. And sometimes the brain signals are also not really detectable. So we had, while testing, we had one person, and we didn't see anything, and that's just because there were not many brain signals to measure. It didn't mean that the person was stupid or something, but sometimes that's just so. Sometimes it's a little bit finicky with using brain signals. If you're doing presentations like that, but that's also the fun thing about that, of course. In this case, we have a 4-channel EEG headband, so that's kind of the new unicorn black. And what is happening is you have the headband goes over Bluetooth, low energy to the computer, measures the engagement score, sends it out over Wi-Fi to the hyperpixels. So those have Raspberry Pi 0, W2 on there on each of these screens, and then sends it out to the screen rest. And that's kind of what is happening around the clock, sort of. So there's a little bit of validation between the engagement and the rest, and also what I measured, like what I mentioned before, that the pupils are never fully open and never fully closed, sort of, in data. And again, this dress is fully 3D printed again. So here you can see a little bit of the reactivity of Sean.
Think of a cute dog.
He was thinking of a cute dog, and then kind of these eyes start to react to that. So yeah, it's a really fun dress to have on. I sometimes wear it as well. So to the last part is prototyping. I already mentioned about that. Most of my dresses have different versions. I'm currently making a version 3.0 of my spider dress. It's at a printer right now, so I'm very happy with that. This was the first one. It was laser cutted, and it had over 200 screws, which it looked really cool, but every time when I went to a presentation, I need to kind of screw all these screws in. So that was why I decided later on to make this kind of the 3D printed one. The cool thing about this was the system was very, very light, so I could make really rapid movements, which I cannot do with the 3D printed version because it's a little bit more heavier, sort of, in regards to the system. So that's the kind of the nice thing if you're thinking about a more lightweight version. The interactions of this dress and the movements are a little bit more defined, sort of. Especially this one is called the You Can Steal, I really like. And also the smoke dress has different versions. The one that I showed you was, I think, version 7, and this was the second one. I do a lot of workshops and things. One thing that I really loved teachers in Vienna picked up. So that was not me, but teachers in Vienna, they worked with Lego Mindstorms, and they worked with the children to actually redesign, like recreate my designs with Lego Mindstorms. And one thing is to 3D model them, to 3D print them is already pretty hard. But doing that from a medium of Lego Mindstorms is pretty tough, much more tougher, because you need to work with the constraints of a real existing design already. So I told them that I will show everybody how badass they are, and their system is also really working. So they started to recreate other things as well. So like this is the cocktail dress. So they also made out of Lego Mindstorms, and these are young kids, sort of, and they proposed it back. They presented it back at Robo Exotica, which is a really cool festival for robots, cocktail making robots in Vienna. It happens every December, and they presented it back there again. So that's kind of the cool thing about kind of open sourcing, which I'm a big part of. Make and share with your community, and of course you can do that in a lot of different ways, from sharing your code to sharing your 3D files, and also the OpenBCI community from San Francisco. So a lot of my designs you can find back on things like Instructables and Hexter.io, so how to make your own robotic cocktail dress. These Lego wings are kind of cool. I needed to put a disclaimer by how to get fashionably struck by lightning, because I was in between 2 times 500,000 Tesla coil, voltage of Tesla coils, and I made my own Faraday cage dress, and I'm explaining you there how to make it, but Instructables asked me to put a disclaimer in there that you should not make this at home. So you're not allowed to make that at home. So I try to really document the process, sort of put little videos of how that works. This was an illegal build from Lego. I also need to know that it was not an legal build, because I'm bending some of the parts of the Lego parts in there, which is not allowed, but it was needed there. And also this dress is kind of cool. It's an easy way to make your own robotic dress by that round part. You can sandwich between fabrics, and then you can hang it on motors. You can put feathers. You can do anything with it, so you can easily make your own robotic dress. The last thing is, if you are putting things online, it's good to really document it well. So I already always put everything out there. I test it a lot, with friends, to see if what I put out there is really there, because people are going to invest in buying these little electronic components and all of that stuff. So you want to make sure that, of course, everything that you have in there is worth making this product. And then I do a lot of workshops with children or mature children all over the world with it as well. So I wanted to close down with, make cool stuff, learn from it, and open source. And thank you so much.
Thank you very much, Anouk. Would you like to join me on the question sofa?
Yeah.
And we will open it to the audience. I'm sure everybody's got lots of questions. So if you've got a question, just put your hand up, and Linnea will bring the microphone to you. There's a question.
Did you start more with the costume side of things or with the tech side of things, when you became interested in what you're making?
Yeah, I started with women's garments when I was 14 years old. I already knew that I wanted to do something with fashion, so I started pretty young. You can do that in the Netherlands. And then when I was 17 years old, I started with robotics, and then I started to combine the two, sort of. But first I started with, I wanted to understand the body first and making designs around the body. And then later on, I started to integrate the electronics and the technology sort of in there. So it was kind of hand in hand, but I did start, first with the design aspect. Yeah.
Did you teach yourself robotics, or did you go somewhere to study it?
I studied interaction design in Sweden after my fashion studies. And then I just mostly hang around a lot at that time, hackerspaces all over the world, in Vienna and all of that stuff. And there were a lot of people always asking questions and being curious, sort of. But partially what I learned was the machine learning side and the robotics side, but most of it I actually learned by making stuff myself, by failing a lot, so because that's also part of it, sort of, and then sometimes also the fun thing. But yeah, I must say that I learned, I think, more from the things that I scavengered myself. Because it's a very hybrid thing, you know, because that's also when I'm putting these things now in universities and such things, it's combining a really weird kind of interdisciplinary thing, because there's something of architecture, engineering, robotics. It's not something that you learn in school right now, for example, you know, so it's very hybrid and very interdisciplinary. But that's also why I'm very much always fighting for having more interdisciplinary things in universities, in schools, because it's so important for very hybrid professions like this. So, yeah.
Tracy?
That was beautiful, fascinating, and I love all the connections between different disciplines and how you bridge lots of things. I wonder, most of your work is interaction between humans and the fashion or whatever you're making, and I wondered, have you built a robot, or do you plan on building a robot, or where do you stand with a non-human robot?
I think, yeah, my field is like wearable electronics, so like wearable robotics, sort of. So I like it when the robot is on your body and can learn from you. The more it's on your body, it can learn from you, of course. Yeah, I do, of course, like other robots. I met a lot of famous robots, like Sophia the robot and all, and we always talk about like then creating a robotic dress for the robot, you know, such things. Yeah, I think it's just really interesting what is happening around robotics, about social robotics, and all these topics right now, sort of, you know. But physical, like humanoid robots, I have not built. I did build exoskeleton. I did exoskeleton design, and especially for females. It's a problem because exoskeletons are often made for men, and the gait is off for women, and also the aesthetics. I see a lot of people in the streets, they walk in the wrong way, and I can see because the females don't want to wear an exoskeleton because they're not pretty, sort of, you know. So that's one big thing that is still very much needed, is like more aesthetics and more exoskeletons for females, for example, you know, and assistive devices. So yeah, so it's mainly around the body, so not necessarily the robot itself. Yeah.
Good question. I think one thing that currently is being asked of anybody in tech is, how do you see AI coming into your work? Is it something you're going to embrace and embody into the dresses, or?
I have my own things, my own ways. Of course, I work from the ground up with machine learning, which is a part of artificial intelligence. Yeah. Like it's deep learning, machine learning. Yeah. So it's already there. I do not like hypes too much, because whenever there's a hype, there's a downer, sort of, you know, and I'm always afraid of that. And the new thing is, of course, that robotics also become a big hype, and the wearables were a big hype, and yeah, so I do not like the hype culture, sort of. So yeah, my systems are most often closed loop systems, but they do at other points, especially with the body signals, they do have a lot of machine learning. Yeah, so it's applied in a different way. There is a lot of problems. Also, a lot of females are like, yeah, should I step into this field because of AI? And they're afraid of that. But I do see that AI is more often used from the software side. Yeah. And sorry for the software developers here, sort of, but they find their ways as well. But the hardware side will never really leave. So we need much more people in the hardware side, which is robotics, which is the creation of new devices and all of that stuff. So, yeah. Yeah.
With the change, like technology's obviously changed in the 25 years you've been working in this. And one of the things that seems to me is that 3D printing is now much more available. Mm-hmm. Do you see people being able to design and build their own things in their home in the near future, or is that still a long way off?
No, I know a lot of people with 3D prints, especially with 3D printing on fabrics and meshes. Yeah. You can see a lot of people around me have something 3D printed, whether it's like earrings or something. But the coolest thing is that you can print something for yourself to wear in the evening or something like that. So yeah. I just love the do-it-yourself fields and aspect of that. Yeah. Yeah.
I mean, it's great how all your stuff is open source as well, and you're really pushing that. Mm-hmm. So that's really good that you've got that sort of sharing attitude going on there. Do you have anything that is commercially available? So if someone wanted to buy the Swarovski necklace, for example, is Is that available commercially, or is that?
The Swarovski necklace, they're researching to make it like well, some of the ideas. This is one that I could publish, sort of. I also did a lot of research for them that stays there, sort of. And they're researching that, but it mostly takes 5 to 10 years for certain concepts to come out, sort of. The BCI, of course, the brain computer interface you can buy right now. The new one comes out in January, February, around-ish, the band, sort of. Yeah. I used to do some collaborations with, for example, I had a Pink Teensy, which is a microcontroller, but it's, you cannot order that anymore. But I would like to make a new board, maybe, that's, because the boards that we're currently using are like square. The round boards always work much better, for example, in garments and such things. So that's always a fun thing to make and to have.
Thank you. Any more questions? Yes, there's another two.
What was your first inspirational sources when you started your journey?
Can you repeat that? Sorry.
What was your first inspirational sources when you started your journey in this field?
I think I like, two things. I love mechanical engineering. I grew up in the Netherlands, and the place that I'm from is Beemster, is the first so-called polder, and we had a lot of windmills around it. And I was always very obsessed with the windmills, how they do multiple things, but also all the mechanisms. So that got me from young on inspired for mechanical engineering and gears and such things. But then later on, when I started to be 7, 8, 9 years old, we had a lot of things like MTV, and I saw how different people were expressing themselves using their garments, and I was like, that's quite interesting. But I was thinking like, but if I put a happy dress on in the morning when I'm happy, in the afternoon I'm not happy anymore. I want to disappear, but I'm still wearing that same dress. So what if these garments can change, or can change with us or with our emotions? So I think like all of these ideas that I had, like, this is quite interesting. I started to kind of combine into creating these things that can react and move and kind of have its own agency or speak on our behalf and such things. So it was a little bit sort of, from the mechanical side, it's kind of, things like inventions like a windmill. And then from the fashion side, it was definitely that fashion is there to express us, right? So how can you do more with that? So,
And what was the first thing you made you're proud of still today?
Well, they're all my babies, so I cannot say that I'm proud of one or the other. Some collaborations are fun. Some things that I made with people around me, or that I made myself. I think they all have something special, and they all have a red line. It's all my research, so they all form together a red line of questions that I have that I answered by making these designs, and then refer that back and test it out with an audience, for example. So,
Another question?
Yes, hello. Just a question about lighting.
Yeah.
You studied robotics, you studied electronics.
Mm-hmm.
What's your inspiration for the lighting? Do you work with a lighting designer when you're integrating lighting into a costume, for example?
No, would be fun. But I do all these things myself, sort of. I also don't have a team.
Self-taught?
With lights, I just look at different lights. I used for a long time the 50-50 lights, or anything that is like small enough, what I mentioned. When I want something really strong, the Rebel lights came out, so I'm always looking at new kind of lights and ways. I love some of the way that we spoke yesterday about, from James Turrell to some of lighting designers that do things in a really nice way, in a really almost you don't see, the color washing is perfect, versus sometimes you want really to show something really heavy, so you go from flashy lights. You can do a lot with lights and behaviors. Sometimes they're a little bit more secondary to my design, because the first means of interaction would be the robotic part, like the spider dress. But when it reacts, there's also light coming out of it at the right moment to answer to that kind of behavior that I want to create while making a dress, sort of, like the smoke dress. When the system goes on, the lights also start to pulse when the smoke goes out, and it almost looks like the smoke comes out much more volumetric because of the use of lighting in there again. Whether another, like the pangolin dress, it's really reacting one-to-one one of those 1024 channels, so it's really flash, boom, 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 and you can also see that with the reactivity in the dress, sort of, you know. So that's it. I used it more from a technical side, but also to create a certain, and to enhance a certain behavior or interaction, I think. So, yeah.
Thank you. That's amazing stuff. If people want to know more about your work and want to follow you, what's the best platforms to find you on?
LinkedIn, Instagram, what do I more use? Facebook a little bit, but yeah.
LinkedIn, Instagram.
Yeah.
So, okay, so we'll send some links out afterwards so everybody can click on and follow your work. Thank